we have on our screens. Please ensure that everything is visible, and we are not going to go through the instructions. We shall start directly from the questions. Okay. Question number 1, it's about climate and weather, and under that line we are given a synoptic weather map. Therefore, we need to analyze it before we look at the questions. Okay. This is a map of South Africa that has got a low pressure in the interior, which we know as the thermal low. There's also a high pressure on the west, and there is another high pressure on the east. You all know, learners, that this is the South Atlantic high pressure. This is the South Indian high pressure. Okay. And when you look at their positioning, they're a bit far away from the coast. But even when you see the cold front, is also a bit far away from the coast. Okay. So when you look at the questions, they say, refer to the sketch below, synoptic weather map. Complete the statements in column A with option in column B, page 4. Write only Y or Z next to the question numbers. Let's go see the questions. Questions are here. 1.1.1. It says the synoptic weather map illustrates a typical condition. Which typical condition? Is it winter or summer? When we look at the map here, there is a thermal low in the interior, which we all know that the thermal low only develops in summer. And when you check the positioning of the anticyclones and the cold front, it clearly indicates that the map is summer because it's far away from the coast. Therefore, we take that. Okay, line A to A represents, we come here, it's A and it's A, and it is an elongated high pressure. And we know that if the high pressure is elongated, it forms a ridge, which is Y. Next, the air pressure reading of I over B is thus hectopascal. We come to B is here. When you check here, the readings of B, if you take it from here, because it is decreasing, the options that are given, we don't have anything that is below 1,000. Because when you minus here, it will give you 1,000, and this one 996. Yet the options we have, we don't have a 996. Therefore, we shall avoid using that route, and we use another route. The other route we can use for B, we can start from this high pressure. Remember, a high pressure, temperature increases towards the center. That means it is decreasing outward. So if this is 10, if this is 10, if this is 10, 20, and the interval here is 4, therefore this is 10, 16, that means this one is 10, 12. Okay. Do we have that option there? The option is available. Even when you check here, if you use this one, it will give you 10, 12 as well. But this is 10, 16 minus 4, it gives you 10, 12. So when you use the high pressure, it will give you answer B. So the answer for B automatically is Y. Next one, the air pressure is deeper around which station model? Is it at D or E? We come here, this here, is here. But when you look at here, it's a warm sector. When you look at the gradient here, the speed of the wind here is indicating it's up on the station model. It's 25, yet here is 10. So when you use the isobars, if you try to use the isobars, since they are so close to each other, that means the gradient is steep and the speed is high. Therefore, D becomes the answer. And D is for Y. Okay. D becomes the answer for the answer here is Y. Then you go, the northeasterly winds at Durban. It's influenced by dry saturation. Let's go to Durban. Durban is here. Since Durban is here, and it's around the high pressure, low pressure is in the interior here. Simply it tells us that since it's a high pressure there at Durban, we can clearly say that high pressure rotates anti-clockwise in the southern hemisphere, which is why. The unstable weather conditions at weather station C are due to the development of which front? The C weather station C is here. Okay. It's saying that the unstable weather conditions at weather station C is due to the development of which front? Obviously, it can't be a cold front because there's no cold front here, but because it is a summer time, the most common front that develops in the interior is a moisture front. Therefore, here we have Z. Which of these station models illustrates the following weather changes at F in the next 24 hours? When you look at F is here in the next 24 hours. That means the air pressure, which is basically on top. If we consider the conditions, the direction of wind changes southwesterly, okay, and the temperature decreases by 4, the air temperature, that's Z. Go to 1.2. 1.2, it is indicating the slope aspect issues. You have this slope that is getting direct sun, and this one is in the shadow zone. Okay, let's try to answer the questions. The relationship between the slope and the sun's rays is referred to as aspect. The surface from A to B is intensely heated because surface from A to B is intensely heated because number one, reflection fog, the higher altitude, receiving direct sun rays, B at a lower altitude, and also receiving oblique sun rays. So the answer there is C. Okay. Dense vegetation is found. Dense vegetation is found are we there? No, we're done with this one. Okay. The climatological phenomena occurring at sea is this here. Okay. Therefore, when you look at the options that are given, advection fog, when it passes the cold surface, on the right, radiation fog, when it's cooling close to the Earth's surface, terrestrial radiation, when warm air rises at night, and frosty pockets. So when you check C, C is here. Okay. So frosty pockets or radiation fog, condensation. So the answer here is A. Dense vegetation is found in the shadow zone due to why? It's going to be conditions. Diagram to analyze the urban center. The sea temperature is higher here. The wind directions towards the CBD. These are buildings and the trees around, which is the rural area. Okay, the graph below represents the change in temperature from rural areas to urban areas. Rural areas are colder, urban areas are warm. Temperatures increasing. Therefore, this one qualifies to be the answer. The reason for the change in temperature is due to the reason for the change in temperature is due to, let's say, change in temperature in the urban area. Obviously, it's not natural vegetation. So wherever there is one is wrong. Okay. So 2 is right. So it's due to artificial surface. So here we shall have artificial surface, which is Roman number 2. And then dash stormy water systems. So the answer is with the rate. So yeah, it's C. The wind direction from the rural areas to urban areas influenced by such temperatures. Wind direction. Why do winds move from rural to urban? Okay. The urban are warmer. One. Yes, the urban areas are not cooler. The temperatures influenced by the warmer temperatures. It is true. And the air pressure in the urban area is lower. Okay. So the answer is Roman number 5 and 1. Roman number 4 and 1, which is B. 1.8, the urban 1.2.8, the urban area will experience cloud cover with dash precipitation than the rural area. So there 1.28, the answer is A. Okay. With the infograph. There is a well-developed cold front from the mid-latitude cyclone reached the Western Cape on Thursday morning. It brought rainfall, which spread to the southwestern parts of Western Cape, the town and Cape Argus, and reached the southeastern Cape late afternoon. The bulk of this rain fell over the southeastern parts, Maso Bay, inside the southwest coast of the south coast from the afternoon into Friday morning, where rainfall increased over 36 hours. The graph is indicating how it happened. According to the infograph, Cape Town, Cape Argus, which is also the way it increased, the map and the cross-section. The first question is, the mid-latitude cyclone mentioned in the extract is in which stage? Already in the extract, they have said a well-developed cold front. Well-developed cold front develops in a mature stage. So the answer here is mature stage. Give a reason for your answer. The extract has already stated that well-developed cold front. There's some other answers that you can give, like the severe rainfall that is spread all over, so on and so forth. Why did the rainfall mentioned in the extract spread all over Cape Town? Why the rainfall mentioned the extract spread all over, spread from Cape Town to Maso Bay and Kensana? Because the cumulonimbus clouds, the CB clouds, cumulonimbus clouds grow wider, and taller, covering the white area, which is indicated that it covers now from here to here, because this is the cold front, and the CB clouds are growing wider like this. It is basically being positioned to cover this area, meaning that even the rainfall will be spread all over the area. Also, you can also consider that the system is moving from the other side. Basically, it's the CB clouds. You go to the graph and determine the lowest and the highest rainfall in millimeters recorded in the Western Cape over the 36 hours. So the graph is here. Okay. And when you look at this, it is also indicated in the infograph that into Friday morning, the rainfall increased over 36 hours. So we are considering at the lowest is 15, the highest is 40. You can say lowest 15 millimeters. Please don't forget the units. And the highest is 40 millimeters, because units are very important. With reference to the cross-section, explain how the well-developed cold front results into a heavy rainfall over the Western Cape. Reference to, so here we consider that the cold front, warm air rises, continuous rising of warm air, continuous rising warm air, warm air rises, development of cumulonimbus cloud that are responsible for the heavy rainfall all over Western Cape. How will the heavy rainfall negatively impact natural environment? It will result into soil erosion, soil being taken away. Okay, that is number one. Number two, it will also result into flooding. Also, you can consider others like disruption of the ecosystem, Here we go to a tropical cyclone. Tropical cyclone, when you analyze it, you can come to a conclusion that this was in the southern hemisphere because it rotates clockwise towards the center. Okay, rotation is clockwise towards the center. Also look at the position, the dangerous quadrant, which is on the bottom corner. Okay, that one condition that is required for the development of tropical cyclone. Here we know that temperatures must be above 27 degrees C. Okay, there must be the temperatures must be above 27 degrees. One mark, the temperatures above 27 degrees C. Also look at the warm ocean as a way. Look at condensation, continuous condensation. All those are conditions. We just need one. In which hemisphere did this develop? This is the southern hemisphere. Give a reason for your answer. One, clockwise rotation. A into a low pressure system. Then you can also look at the condition number two as the position of the forward to left quadrant, the position of the dangerous quadrant. Any work, because it is one, it's 2 marks, one answer. Refer to A and B on the set line. A and B. You should know that A is the I, B is the I wall. difference in clouds. A in the cloud cover, A has less cloud cover. Whereas B has got dense cover. Explain why there is a difference in cloud cover. A and B. A descends, yeah. At A descends, whereas B rise. Okay. Another reason we say at A there is no formation of clouds. That's why it's clear skies. Whereas at B there is formation of cumulonimbus cloud. Why there is the strongest wind found in this leading quadrant? Why is there strongest wind found there? So here we say it is because both the rotational winds, and the translation winds and the translation speed, okay, are acting at the same, in the same direction. So both the rotation, because remember it spins clockwise and the system moves from east to west, so they are all acting in the same direction within that dangerous quadrant. That's why it's the strongest wind there. Draw a sketch of a tropical cyclone in the mature stage as represented by a synoptic weather map. In the synoptic weather map, we normally have it in the circle where we have isomers. So they say at least air pressure reading at the center of the tropical cyclone. So we say this is 992. This is 996. This is 1000. And it's at least the 4 isomers indicating corrective spacing. So 992, 996, 1000. Those are 3. 1, 2, 3. Oh, sorry. This is 992, 996, 1000, 1004. This is hectopascal. Hectopascal, hectopascal. And then the symbol, yes, the symbol will draw it here. Sorry, it can't be seen properly, but the symbol is drawn like this, but you draw it here in the center. Okay. Go to the next diagram, refer to the berg winds here, indicated for us the berg winds here. The map. First question is, name the high pressure cell and the low pressure cell indicated in the sketch map that leads the development of the berg winds. So this one is at the coast, this one is in the interior, and it is a high pressure. Therefore, the high pressure is a very high pressure of the continental, and the low pressure is the coastal low. So which sketch A and B represents the formation of the winds. Of course, back winds are winds that are descending off the escarpment towards the coastal low pressure due to the influence of the pressure gradient. See high and low, and winds move from high to low. As they move from high to low, they go over the escarpment. The two diagrams that can indicate the proper is B. Okay. So here we say B. Give a reason for your answer. Winds are descending from the high pressure to this high pressure is in the interior to low pressure at the coast. Also say that the heating is the dry adiabatic erupts. Right. The winds are heating at a dry adiabatic erupts rate. As you descend, the temperatures are increasing. Okay. Explain why cloudless conditions are indicated at the station model X. Okay. Where it's X, X is at the coast. Why do we have cloudless conditions? Because winds descend to the coast. So you remember when the winds descend, no cloud formation. Okay. And also you can also consider that there is too much evaporation. As they descend, they heat up. Okay. The paragraph of across the 8 lines explain the impact, impact negatively on the nature vegetation, suggest the strategies. Now, when you consider that, we're going to say that wildfires develop. That is one of the negative impacts on the vegetation. Vegetations will bend down. Okay, but what are the suggestions? The suggestions we can say for us to control wildfires, watering of plants, watering of the vegetation. This means that if vegetation is wet, it's very difficult for fire to spread. Okay, that's number one. Number two, we can also say that dividing the vegetation with water sources, which makes it difficult for water to jump from one point to another. Also, deploying tower guides to observe the extent of the fire and try to stop it. Now, question number 2, which is the morphology. We are interpreting diagram given to us. Diagram here, we must write the answers according to the diagram here. Which one is a river source? Oh yes, so when you look at where the first order streams are, here is the other side. The data that indicates that one is B. So here, B. Okay. When you look at the water table, would say the water table is an interflow highline area between the two drainage, tributaries in the same drainage basin. It becomes A. The drainage basin, it is C. Okay. Then the river mouth, it is E. Watershed, it's H. Confluence is D. Infiltration, F. Okay, 2.2. The sketch is given, so we are using it to answer the questions. The sketch illustrates dash a river. Which river? Illustrate obviously the longitudinal because there's a source somewhere and the mouth here. So that is the longitudinal. Next. Sorry, I was still resuming here. I was saying that the sketch below indicates the video process. We're answering questions 2.2 to 2.4. Here we have a longitudinal profile. We know that the longitudinal profile, we see the diagram from the source to the mouth. But here we are only seeing the mouth. We can't see the source, so it can't be a longitudinal profile. Then when we proceed, we have a plan view. A plan view is when you see the horizontal surface. At least you can see the horizontal surface of this one. So oblique view, obviously when you see it from a certain angle and the cross-section mouth bank to bank. So the answer is a B. The trivial landform of feature shown on the sketch is what? The meander. Okay. Now, the trivial landform of feature on the sketch occurs mainly in which spots? Middle, upper, lower in the youthful state. So it's a lower. The dominant demorphological process taking place in this course we have just mentioned is deposition. Now, for the next one. The cause of river rejuvenation shown in this page is what? So when you check here, see this rise in the sea level, that is wrong. Decrease the volume of water, that can't cause drop in the sea level, then headward erosion. So the answer becomes C. The landform feature visible on the sketch is rejuvenated as a result of, is due to the rejuvenation, the landforms of features visible on the sketch due to rejuvenation is or then you have interlocking spurs, which we do not are not clearly visible here, they are not here. But in the valley, obviously that one is there. Paired terraces, we don't see them paired, and then inside the meander. I would say Roman number 2 and 4, which is D. The longitudinal profile of a river after rejuvenation. After rejuvenation, when it has gained its energy. Can't be this one because the source can't be at the lower section. Can't be this one because it can't be concave. After rejuvenation, after rejuvenation. So when you look at this, when it rejuvenates, it hits the rock. I'll go with B. Refer to the pattern illustrated in page A and B. Identify the Dungy patterns that is represented in A and B. So A is the rectangular, B is the dendritic. The nature of the underlying rock type, the underlying rock structure, and the type. So A for A. Okay. The underlying rock structure, igneous. The rock structure is going to be jointed, and then the type is going to be igneous. Explain how the underlying rock structure influences the pattern. Rock structure, joints, rock joints, rock joints are used by the river, find the path, to find the path. The drainage density at B is high or low. The answer is high. Determine the stream order. Stream order for this one, you can see 1, 1, 2, 1, 1, 2, 1. So that means it is 1, 1, 2, 1, 1, 2. So 2 is meeting with 2 to form 3. 1, 1, 2, 1, 1, 2, 3. Okay. So 3 is meeting with 3. 1, 1, 2, 1, 1, 2, 2, 2, 2, 3. Okay. 1, 1, 2, 1, 1, 2, 2, 2, 3. So 3 and 3 is 4. So here is 4 stream order. Relationship between stream order and drainage density. The higher the stream order, the density, drainage density. Explain how the slope and the probability of the rock, underlying rock, influence drainage density at B. That was gradient, gentle gradient, limits water flow speed, allowing many streams to exist on the air and the surface of the earth, and then impermeable rocks. Also allows more water, allows more drainage density to exist on the surface of the earth. Go to rejuvenation here, river capture. We show us what's happening at A and what's happening at B. Which river, A or B, has more erosive power? Answer, I would say, let's check the XP, it's A. A has more erosive power. Give a reason for your answer. Then the lower gradient. You can say it flows faster. Yeah. Any, but they need only one. Identify features C and D. The elbow of capture, and D is the wind gap. Give one characteristic of D. D, which is the wind gap, space with open space with no water or occupied by wind. In the pack of this periodic changes at E. Changes at E. This means speed. That will be the changes. The vary will be bigger than the river, number one. The volume of the water will be less 2, the river will be flowing slower, will be flowing slower, the river will be flowing slower, and the river valley will have or will be detached. Therefore, full of marsh. 2.5. 2.5, we are given the extract of alien plants and so on and so forth. You read through it and understand it. So I've read through the extract. Just going to straight to the questions. How much water is lost due to alien plants according to the extract? You go back and read alien plants are possibly recruited straight on the Eastern Cape Town. Water security, the roots of the plants absorb underground water. The current water loss due to alien plants is more than 100 million liters. So how much water is lost due to alien plants? More than 100 million liters. Give two plants in the extract that Cape Town municipality intends to use to improve water security. Here it says, to address water security, the city of Cape Town plans to extract water from aquifers. That is number one. Plans to extract water from aquifers. Number two, the plan to extract water from underground is experiencing challenges due to alien absorbing water from underground, drilling boreholes and all. Okay. The catchment area restoration or repair is the solution to water security, and alien clearing programs are key to its restoration. So that means there is another plan of clearing the program of clearing, and also here extracting underground water or drilling boreholes into aquifers. So since it is 2 marks, we can also have drilling borehole. Okay, as it is indicated. Describe the positive impact of the removal of the alien plants on the volume of water in the dam. So the volume will increase in the dam. What about the water table? The water table will rise close to the surface of the earth. Why will the removal of the alien plants improve the biodiversity of the catchment area? Why will the removal of the alien plants improve on the biodiversity? So why will it improve? Because it will help to maintain the valuable water underground, maintain the valuable water underground, which is now being used by the plants, okay, or the biodiversity. We can also give the second reason as it helps to stop the alien plants. It stops the alien plants, from reproducing. producing, from reproducing and spreading. From reproducing and spreading rapidly into space. Spreading rapidly. Okay. It also helps to keep water for the valuable indigenous plants. For the valuable indigenous plants. Okay. We go to the last question, which is Mapwork. You have to be in position to analyze this and read this information around. There's Queenstown, officially known as Coman, is a town in Eastern Cape, South Africa. The town lies on the banks of Coman River, which forms part of the Great Kei River system and has refreshing climate, and an abundant water supply from the surrounding rugged mountains. The area's annual average temperature is 18.29 degrees C, which is 2.93% lower than the average of South Africa. Queenstown generally receives approximately 90.83 millimeters of precipitation and has 134 rain days annually. Winters are short, cold, dry, and windy. It's mostly clear year round. Okay. Let's see the questions. Which human-made feature is found at grid frame 3649? 3649. We come here, we check 3649. This is 36, this is 35. 45. So that means this one is 46, 47, 48, 49. So we are dealing with this. How many minutes? The minutes is 41. Therefore, we come here, 49 and 41, close to 50 is somewhere here. So we shall have our line drawn around here. We got the next reading. The next reading says 26:45, 26 degrees, 45 minutes. We come here, we say 26:45. That means it's within this bracket. How many minutes? How many seconds? It is 35 seconds. So 35 seconds, say if this is 30, 35 will be around there. So we go down where they intersect. If this is 30, this is 45. Okay. So that means this is 30 is the half of the two, 35 is somewhere here. So when you check this and this line here, the point of intersection is going to be our feature. So which is that one? And when you check on the key, that feature buildings is this, the road is this, which clearly indicates that from our options given, obviously it can't be trees and spot height can't be. The answer is going to be C. The contour interval on the orthophoto map is dash in meters. You come to the orthophoto map, you check, it's even indicated here. Contour interval, this is the orthophoto map, is 10 meters. You check the options, the 10 is B. The photo map, the photo number of the orthophoto map is, we come to the orthophoto map, we check the code, this is latitude, this is longitude, big block, small block, number 1. So that means it's number 1. When you check here, number 1 is D. Then calculate the area in meters of a farm labeled F on the topographic map. Use the measurements given. So they have given us the measurements and they want the answer in meters. So we come here, we consider meters and which map is being used? Topographic. Therefore, we remember that if it's meters on the topographic, we use 500. Therefore, we come here, we say the area here is L times B. What is the value for L? The value for L is 0.9. So it becomes 0.9 centimeters times 500 times. You can put this in brackets. We come to this 0.7 centimeters times 500. Don't forget that each unit has to be multiplied by the scale. So when you multiply these two, they will give you 450 meters times 350 meters. Meters times meters, you get meters squared. 450 times 350, 450 times 350, you get 1575. 157,500. So it's 1,500 and 157,500 meters squared. Okay. You go to the second one, calculate the average gradient from 6 to 7. Average gradient in the spot height 157. Average gradient from 6 in the block D5 to 7 in the spot height to 7 in spot height 1567. We go to the map. We're using the orthophoto map. Here we see the spot height is here 1567 and 6 is here. So 6 it's on the contour line. What is the reading of this contour line? When you follow it, its reading is here. Okay, so we take these two and we minus them. So when you come here, you say the vertical interval is equal to 1567 meters minus 1420 meters. What's the answer? The answer is 14, the answer is 147. Okay, 147. So the horizontal equivalent is already given 950 meters. So you divide this by 950 meters. What do? We divide by the smallest 147. Also divide by the smallest 147. 147 goes into 147. 1 over. This goes into this how many times? It goes into that 6.46 meters. So the average gradient is equal to 126.46. Don't forget that the gradient is given in the ratio formatting. There is no intervisibility between 8 and 9 on the orthophoto map. Come here, 8 and 9. There's no intervisibility. So they are asking, name the type of slope that is responsible for this. When you check the map, you see that if 8 is here, it's a bit lower than what is here. But there is also a steep area in between. So it forms a convex slope. So here you'll find out that the slope is like this. So if you here, you can't see here. Therefore, this is a convex. Okay? Convex slope. Okay. Come to interpretation. Map evidence indicates rainfall, indicates dash rainfall because of dash blue lines on the map. So the moment you go to the map, you will find out which kind of rainfall. If the lines are broken or what. Let's go to the map. If you check the blue lines on this map, you find that it's not a bit clear, but we can still see. You find that there are broken lines there. Those broken lines, it means they are the dashed lines. Which dashed lines are indicating seasonal rainfall? So we have 2 and 4. 2 and 4, which is the next point, the next question. Explain how the katabatic winds influence the temperature G in block P.1 on the topographic map. Katabatic winds at G. When you check G, let's check on the map. Come here, G is here, just at the lower section, and here is mountainous. So how does it influence? We are going to say it influences the katabatic winds as we shall say that at G, okay, temperature is low. So how does this influence the temperature? At G, the temperatures are low. Okay. Why? Yes, as the katabatic winds, katabatic winds descend over the valley slopes. The table below shows the crops and the temperatures. We have average pumpkins and potted tomatoes. Pumpkin -2, it can grow. This one can grow only when it's above. So which crop, pumpkin or tomatoes, most likely to grow at G? Since G is experiencing low temperatures, pumpkins are likely to grow. Pumpkin. Give the climatic reason for your choice. The climatic reason is that G experiences frost pockets. That's why you see even the temperatures are in minus. Remember, frost pockets is when the temperatures drop below the freezing point. Okay. G experiences frost pockets. Okay. Refer to river at 10 on the orthophoto map. We'll come to the orthophoto map. 10 is here. Okay. And this is a river here. First question is, the river at 10 on the map is generally flowing in which direction? Let's check. When you look at 10 here the contour lines are indicating that it is 1520, 1510, 1550, 149, meaning that here is higher and here is lower. And we know that rivers can't climb the mountain, but they flow down the mountain. Therefore, when you look at that direction, it is the southwesterly direction. Give a reason for an answer. Contour lines decrease southwesterly, which indicates that the reef also is decreasing southwesterly. Okay. Then refer to River H on the topographic map. We got the topographic map. River H is where? River H is here. Okay. When you look at H here, I hope you can see it clearly. When you look at H here, it shows you that here is mountainous. Okay. And therefore, at what stage, in which stage, is it upper or middle course is River H? Because the area is in the mountainous area or the higher lying area, the river is in the upper course. Okay, give evidence. Evidence that we have there is that their first stream order. First stream order is visible Okay, it's 2 marks only. Also, we can say the gradient is steep. Or tennis. Okay, go to GIS. The environmental issue labeled I in block. A2, I in block. A2 is represented as a feature on the topographic map. We go to block A2. A2 is here. I is here. And this, when you check the key, is a dry pan. Okay. So when you check a dry pan, the feature it represents is a polygon. Remote sensing is defined as taking image of the Earth's surface from the distance. Explain how remote sensing is effectively used to monitor this. This is by taking pictures. By taking photos, pictures of the area. By taking photos or pictures of the area. Right? You can take it only when you are in the distance, when you take a picture. Okay. Oh, define the concept raster data. Raster data, it means data in form of pixels, megapixels. You can say images. Okay. A topographic map or the orthophoto map represents this kind of data. Obviously, a photo is the orthophoto map. And lastly, why is the information in the orthophoto map realistic when determining the availability of water in a dam at a specific time? It's realistic because the images taken using remote sensing are clearer. That you can easily see. Also, the features are clearly visible. The water features are clearly visible. Thank you so much. See you soon.
That's what it is.
Good day, good people. We're here to go through this geography paper that we have on our screens. Please ensure that everything is visible, and we are not going to go through the instructions. We shall start directly from the questions. Okay. Question number 1. It's about climate and weather. And under that line, we are given a synoptic weather map. Therefore, we need to analyze it before we look at the questions. Okay. This is a map of South Africa that has got a low pressure in the interior, which we know as the thermal low. There's also a high pressure on the west, and there is another high pressure on the east. You all know, learners, that this is the South Atlantic high pressure. This is the South Indian high pressure. Okay. And when you look at their positioning, they're a bit far away from the coast. And even when you see the cold front is also a bit far away from the coast. Okay. So when you look at the questions, they say refer to the sketch below, synoptic weather map. Complete the statements in column A with option in column B, page 4. Write only Y or Z next to the question numbers. Let's go see the questions. Questions are here. 1.1.1. It says the synoptic weather map illustrates a typical condition. Which typical condition? Is it winter or summer? When we look at the map here, there is a thermal law in the interior, which we all know that the thermal law only develops in summer. And when you check the positioning of the anticyclones and the cold front, it clearly indicates that the map is summer because it's far away from the coast. Therefore, we take that. Okay, line A to A represents, we come here, it's A and it's A, and it is an elongated high pressure. And we know that if the high pressure is elongated, it forms a ridge, which is Y. Next, the air pressure reading of I over B is thus hectopascal. We come to B is here. When you check here, the readings of B, if you take it from here, because it is decreasing, the options that are given, we don't have anything that is below 1,000. Because when you minus here, it will give you 1,000, and this one 996. Yet the options we have, we don't have a 996. Therefore, we shall avoid we use another route. The other route we can use for B, we can start from this high pressure. Remember, a high pressure, temperature increases towards the center. That means it is decreasing outward. So if this is 10, if this is 10, if this is 10, 20, and the interval here is 4, therefore this is 10, 16, that means this one is 10, 12. Okay. We have that option there. The option is available. Even when you check here, if you use this one, it will give you 10, 12 as well. But this is 10, 16 minus 4, it gives you 10, 12. So when you use the high pressure, it will give you answer B. So the answer for B automatically is Y. Next one, the air pressure is deeper around which station model? Is it at D or E? You come here, this here is here. But when you look at here, it's a warm sector. When you look at the gradient here, the speed of the wind here is indicating itself on the station model. It's 25, yet here is 10. So when you use the isobars, if you try to use the isobars, since they are so close to each other, that means the gradient is steep and the speed is high. Therefore, D becomes the answer. And D is for Y. Okay. D becomes the answer for the answer here is Y. Then we go, the northeasterly winds at Durban is influenced by saturation. Let's go to Durban. Durban is here. Since Durban is here, and it's around the high pressure, low pressure is in the interior here. Simply it tells us that since it's a high pressure there at Durban, we can clearly say high pressure rotates anti-clockwise in the southern hemisphere, which is why. The unstable weather condition at weather station C are due to the development of which front? The C weather station C is here. Okay. It's saying that the unstable weather conditions at weather station C is due to the development of which front? Obviously, it can't be a cold front because there's no cold front here, but because it is a summer time, the most common front that develops in the interior is a moisture front. Therefore, here we have a Z. Which of these stationary models illustrates the following weather changes at F in the next 24 hours? When you look at F is here in the next 24 hours. That means the air pressure, which is basically on top. If we consider the conditions, the direction of wind changes southwesterly, okay, and the temperature decreases by 4, the air temperature, that's it. Go to 1.2.